Chapter 6 in Trigonometry is titled Trigonometry. In 6.1, we'll look at angles and their measures. Day 1 has us working with degrees. We'll look at describing angles on a coordinate plane, eventually work with both radian and degree measure. We'll calculate arc length and area for sectors, and then we'll use angles to model and solve real-life problems. The definition of trigonometry is the measurement of triangles, including sides and angles. As we create angle measures on different quadrants, we need to take a look at where an angle starts and where it ends. This is known as an angle in standard position. The vertex of the angle will always be at the center of the coordinate system. The initial side is always where we start our measure, and that will be at 0 degrees. Now, as an angle increases in value, it'll go from one quadrant to another. Quadrant 1 is that quadrant on the top right. Quadrant 2 is on the top left. Quadrant 3 on the bottom left, and quadrant 4 on the bottom right. Taking a look at the angle that's given, it ends in quadrant 2, and that is the terminal side of the angle measure. We start at 0 and we measure the amount it takes to get to that second side, or that terminal side. Now, depending on the direction, your angle will either be positive or negative. Over on the right, take a look at the positive and negative kind of locations. If you have a positive angle measure, it starts with the initial side at 0, and it rotates in a counterclockwise direction. That will give it a positive angle measure. However, if you change directions, still starting with that same initial ray, but now if you go in a clockwise direction, your angle will have a negative measure. So it'll still be the same numerical value one way or the other. It's just where it ends up depending on if it's clockwise or counterclockwise. Let's take a look at the two examples on the right. We're first asked to sketch a 145-degree angle. So now we need to think about kind of boundaries for each of the quadrants. Over on that right-hand side, if we start with our initial ray, that's 0 degrees. At the top, we'd be at 90 degrees. It would form a right angle. If we go halfway around to the other side of the x-axis, that would be at 180 degrees. Down at the bottom, or directly across from the 90, would be 270 degrees. If we made one full loop where the initial and terminal sides would match, that would be at 360 degrees. So the angle that we're looking for is 145. That should be somewhere in quadrant 2. So if we start with our, If we start with our initial ray on that right-hand side at 0, and we want to rotate 145 degrees, well, that's definitely bigger than 90. It's getting closer to 180, so we'll approximate it maybe like right there. That would be a positive 145-degree measure. If we change direction and have a negative angle, that really just means we're changing where it's going to end up. It'll still be the same size and shape of the positive angle, just in a different direction. So now if we start at 0, and if I go 90 degrees in a clockwise direction for that negative value, we're going to end up down here somewhere in quadrant 3. So those angles are about the same size, but notice they end up in different quadrants because one's positive and one is negative. A new term for us to recognize is coterminal. Coterminal angles in degree form are angles that share the same initial and terminal rays. Typically, you would have one positive and one negative coterminal answer. If we look at the picture on the right, notice you have your initial ray over here on that right-hand side. If it rotates in a positive direction over here into quadrant 3, that gets you to your terminal ray. So that's one angle measure, and they're calling it alpha. So just giving it that symbol for the angle name. However, you can also go in a clockwise direction and get to that same terminal ray. It's a different measure, but it ends up at the same spot. and that's beta. That's how they identified that that angle's measure. Since they share the same terminal side, alpha and beta are coterminal angles. And you can see in that second angle measure set that they both share the initial and terminal rays as well. Notice beta is greater than 360. It goes around the whole coordinate system more than one time. Let's take a look at creating some angles, figuring out what quadrant they should be in, and then finding one positive and one negative coterminal angle. The example says determine what quadrant each angle is in. Then find one positive and one negative coterminal angle. The first thing I'm going to do is just graph the initial angle of 58 degrees. That means my initial ray will be over here on the right at 0. Now 58 degrees is less than 90 degrees, so my angle should be somewhere up here in quadrant 1. I'm going to put my measure in this direction, and that's 58 degrees. Now, to come up with one positive and one negative coterminal angle, we have a little formula. And I'm just going to write the formula up above right here. So we'll just kind of default this angle to our alpha value. Well, it's as good as my alpha is going to get. What you'll do is you'll take that alpha value and you'll literally just add or subtract 360 degrees. And we do that because that would indicate one full revolution around the coordinate system. I'm just going to remake my alpha there. All right, so if we want to come up with a positive and one negative coterminal angle, I'm going to start with my 58 degrees and then literally just add and then subtract 360 from it. If we take 58 plus 360, we're going to get an angle that's bigger than 360. We would get 418 degrees. That's an example of a positive coterminal angle. It would go around the coordinate system more than once, but it would end at that same terminal side. If we do 58 minus 360, that will give us a negative direction, negative 302. And what that means is we would go from our initial ray around in a clockwise manner to give us that same terminal side. So we came up with one positive and one negative coterminal angle. Let's try the next one. Our initial angle here is 500 degrees. So we're going to have to figure out what quadrant we end up in. Again, if we start with our terminal side at 0, obviously 500 is bigger than 90, it's bigger than 180, it's bigger than 270, it's even bigger than 360. So if we start at 0 and go all the way around, we've got to keep going. If we take 360 and add 90, we're at 450, so I need to go 50 degrees more. That puts us way over here in quadrant 2. That's our initial value, or our alpha value. So our plan is to add and subtract 360. But we run into some trouble on this one. If we add 360 to 500, that's pretty easy. We get a really big answer. We get 860 degrees. That's a positive coterminal angle. But watch what happens when we subtract 360. If we take 500 minus 360, this is another coterminal angle, but it's positive. So we need another value that would have a negative rotation. So that means we're going to have to subtract 360 again. You have to have one positive answer and one negative answer. If you take 140 minus 360, now we'll get negative 220 degrees. So either of the two angles we first calculated would work for your positive measure. You could have one or the other. You don't have to list them both. But then you have to do that 360 rule one more time to get the negative value. So over here, just pick one. They both are full credit. Just pick one of them, and then make sure you include that negative measure as well. In example C, our angle was already negative. That means we're just going to go in a clockwise direction when we sketch its location. So 0 degrees on the right, negative 134, well the bottom would be negative 90, halfway around would be negative 180. So we've got to be kind of somewhere in between. We'll kind of put it right in the middle right there. So that would be our initial value. We'll take that angle, negative 134, and we'll add and subtract 360. Coterminal angles are super easy to work with. If we do negative 134 plus 360, we're going to get an answer of 226 degrees. And if we do negative 134 minus 360, that'll be a much bigger negative angle value, negative 494 degrees. Both of those angles would have a terminal side that matches down here in quadrant 3. If you haven't already been using a calculator, now would be a great time to go grab one. What we're going to do next is take a degree value and then a portion of a degree and convert it to minutes and seconds. The template we'll follow is that 1 degree is equal to 60 minutes. So 1 dash would indicate a minute's value. And then 1 minute is equal to 60, and then you do 2 dashes, and that would be a second's value. 1 degree would then equal 60 times 60, or 3,600 seconds. So those will be some values that we're going to work with. If you're given degrees, minutes, and seconds, and you're asked to convert to decimal form, this is where you definitely need your calculator. We're just going to add a bunch of things together and put a decimal answer as our final result. The 30 degrees is our whole number, so we'll do 37 plus. The 21 with a single dash means 21 minutes. That means 21 out of 60 for the decimal form. And then we've got the 33 with the double dash. So we'll add 33 over 3,600. So this is the decimal form for the minutes in the degree, and then we'll add to that the decimal form for the seconds in that degree. And you literally just plug this all into your calculator. 37 plus 21 over 60 plus 33 over 3,600. Rounding that to the nearest 4 decimal places would give us 37.3592 degrees. And to work the other way, we'll do a little bit more detective work. We'll talk about that in class.